You think you're funny, do you?
So I asked myself, so if I said, do my ragamuffins know what a line plot is or what a bar graph is, and do they care? The fact is that for most kids, there's no reason to know how to manipulate, analyze, or synthesize data. In this case, when we use graphic organizers, because that's what a line plot is, that's what a bar graph is, we can organize the information in such a way that quickly we can look at the picture that it's formed and get to some conclusions to understand what's going on in the situation. So today, we're going to jump in and look at a book club challenge to see how we can interpret the data. I love these as a teacher. It really inspires a lot of reading. In this case, 5 friends are tracking the number of books that they read in June, and they recorded the average number of pages. Each kid had a different number of pages that the books were about. The results are shown in the table below. Use a line plot diagram to show who read the most books. So we have to find out who read the most books using a line plot, and then we have to use a bar graph to also show the pages read. We know there are 5 friends. We know that we have to track the number of books that were read. The average number of pages are given. We have to use a line plot diagram. We'll find out what that is, and a bar graph to show the pages that were read. So the table that they are going to give to us has all the data nicely organized. The table is also a graphic organizer, but we can get more into the details. We've got books read, and we have the average number of pages. We know Ava read 6, and we know that Liam read 12 the most. As far as the average number of pages, we know that Liam read 50. We know that Ava read 120. Basically, Ava's books were much longer than Liam's, more than twice. The question asks us to use a line plot diagram to show who read the most books. A line plot organizes all the information in a picture way to help us quickly understand what's going on in the situation. So a line graph is actually based on a number line. It's kind of a fancy number line. Each of the 5 kids is organized nicely on the number line, spaced out so that we can have enough room to put an X for each book that the kid read. We try and keep the X's the same size and the same spacing so that they make towers or columns that allow us to easily look at them and figure out how do they compare. You can see Liam obviously read more books. He's got 12, and Ava has read only 6. Turns out that just by looking at these columns, I know how the kids compared in the number of books that they read. Graphic organizers help us do exactly that. So bar graphs are similar to line plots. However, I find bar graphs to be more sophisticated because there's a y-axis that is clearly numbered. So it makes it easier, I find, to just take a look at the bar and compare the heights along the y-axis to figure out how the different kids in this case compare. So the x-axis is horizontal and it's labeled. In this case, it's going to have each of the 5 kids' names. And the y-axis is vertical and it's numbered. We're going to have the number of pages that is it the number of pages or the number of books? We'll find out in 1 second on the y-axis. So it's a two-dimensional coordinate plane, and the bars compare the amounts by label. Whoa, wait 1 second. So I know I said in a coordinate plane, you've got the x-axis that's horizontal and the y-axis that's vertical. And along the x-axis, you normally have labels, and along the y-axis, you normally have numbers. The thing is, that's when the bars are vertical, right? That's how it's almost always. But every now and again, someone decides what they want to do is make the bars go across or horizontal. In that case, they'll actually flip the way that the bar graph is organized, and the y-axis will have the labels, and the x-axis will have the numbers. It's up to them. When looking at the table to figure out the average number of pages, we look at the last column and we show Liam has 50 pages in his book, and Ava has 120, and the last digits all zeros and fives. When I'm organizing my number line, I have the names of the kids along the x-axis. My vertical axis is the y-axis, and the y-axis is going to help me with the numbers. I have to make sure 120 can be shown on that vertical y-axis. If I count by 20s, I can get all the way up to 120. Convenient? I don't know. Of course, I worked it out that there'd be 6 spaces. And I'm going to divide those in half just so you know I count by tens with the smaller increments. So now I'm going to use a ruler to figure out where should the top of the bar be for each of the 5 kids. Liam had 50, and Sophia right in between 80 and 90 at 85. Then I look at the table, I see Ethan has 70, and Ava has 120 average pages read. Noah has 65. That's right in between 60 and 70. So I'm going to make a line across here and then come on back in and complete the bars. I'm going to color in each of the bars just to make sure we can differentiate them easily, and also it looks pretty. We know Liam read 12 books, Sophia 8. Ethan, an average of 10 books altogether, Ava 6. So I need to find out the total number of pages. In order to do that, I'm going to use the distributive property, which we also know as the break-apart rule. And average means about. If I read 3 books that were about 10 pages long, in order to find out how many pages altogether, I would multiply 3 by 10. To get 30 pages. Multiply the number of books by the average number of pages to get the total number of pages. I hope that makes sense. Liam had read 12 books that were 50 pages. 12 times 50 is the same as 12 times 5 times 10. Which is the same as 60 times 10. Liam read 600 pages. Sophia, her situation, shows that she read 8 books that were 85 pages long. 8 times 80 plus 5, which is 8 times 80 plus 8 times 5. 640 plus 40, which equals 680 pages for Sophia. Ethan's situation. Ethan read 10 books that were 70 pages long, which is 700 pages total. Ava's interesting because she read short books. She read long books, but only 6 of them. 6 times 12 times 10, 72 times 10, which is 720 pages altogether. Only 1 kid left. And that's Noah. Noah was sort of in between. He read 9 books that were 65 pages long. 9 times 65 is the same as 9 times 60 plus 5. which is 9 times 60 plus 9 times 5. 9 times 60 is 540, and 9 times 5 is 45. The sum is 585 pages for Noah. Here's the information that we have about all 5 kids, and we can see Noah read the fewest number of pages and Ava read the most. She read 720 pages altogether, which is honestly quite impressive. Didn't see that coming since she only read 6 books. The challenge I have here is to show those huge numbers on my y-axis. I have 1, 2, 3, 4, 5, 6 increments. I'm going to show numbers from 585 all the way up to 720. So the easier thing to do is to simply start not at 0, but with 500 being the lowest labeled amount on my y-axis. And I'm going to count by 50s from there. So 500, 550, 600, 650, 700. 750 will mean I can show 720 pages very easily and clearly when I draw the bar graphs. So like before, I'm going to start with my ruler and I'm going to draw a horizontal line just to show the top part of the bar. So Liam read 600 pages, nice and simple. I've got Sophia next with 680 pages, so that's almost to 700. Ethan read 20 pages more, exactly at 700. Ava read 720 pages, 20 pages more than that. And then Noah came through at 585 pages. Noah actually read the least number of pages, even though he read 9 books. We'll do the same thing, finish up the bar, color it in. That way we can tell easily by looking at it how one compares to the next. Average number of pages compared to total pages bar graphs. A ruler here will allow us to compare the height of the bar graphs. In the first one, for average number of pages, the shortest bar graphs means the shortest books overall. Liam wins for shortest books. And then finally, Ava wins for the longest books. When we look at the total pages ranking, we have to multiply the number of books by the averages. And in this case, by just looking at it, you can see that Noah has the fewest pages, and then Ava has the highest bar, showing the most pages. So Liam ranked 1 and Noah ranked 2, and they actually flipped their rankings for average number of pages and total pages, although the numbers were still pretty close. By the time we get to Ava, we find that Ava has the longest books, and also she has the largest number of pages, the most. Let's take a look at the books red line graph compared to the 2 bar graphs. For the fewest number of books, Ava wins with the shortest column. And then you can see that Liam has 12 X's. He has the tallest column, meaning that he's read the most books. So for books read, we see that Liam had the most books. However, when we take a look at the average number of pages, he had the shortest books, and he almost had the fewest pages. So we can write down here that Liam read the greatest number of books. You'll remember there were 12. However, they were the shortest books, so he must be into more picture books, or I'm not certain what it could be, but they're definitely quick. He doesn't have the stamina to read longer books. When we look back and we take a look at Ava, she's read 6 books. However, her books are the longest, and she read more than anyone else. I think that Ava is probably a really strong reader, or She's able to read for longer periods of time. She read the fewest number of books, but they were the longest. She read more than anyone else. I want to read like Ava. At the end of the video in the descriptions page, I have a link for a practice pack. And that practice pack has 3 problems with 3 different situations of data that you can actually, in fact, you are expected to list that information, to organize it using a line graph and a bar graph for each of the 3 situations. This will give you a chance to really practice taking data from a table, putting it into a bar graph and a line graph, and drawing some conclusions about it. I hope you practice because, yes, practice doesn't make perfect, but it makes you smarter. So when we began this, we had a table with all this information. We had 5 different kids. We had the number of pages read, the number of books that were read. And it's honestly quite difficult to just look at a table and understand exactly what's going on, even though a table does help me organize the information. But once I use the graphic organizer, once I put that data into a line plot, I had those X's all lined up. I could just look right away to see which column of X's is the tallest and the shortest. I could look at how all the data was organized. When I used the bar graph, I could do the same thing. I had the separate bars. I could make a decision really quickly by just looking at it to draw some conclusions about the data. So graphic organizers help you analyze the data and help you synthesize the data and come to conclusions quickly and easily. So I hope that helps. Okay, bye.
I need to know everything, who and the what and the where, I need everything. Trust me, I hear what you're saying, but act like it's new what you're telling me. I'm curious, George, I hop in the Porsche, it's 5 and a horse, I'm ready for war, I'm coming for throats, to turn to a ghost, I need to know everything.